Let's take a look at a coaster. First, let's take a look at the crest of a coaster hill, and then we're going to take a look at the dip of a coaster hill. Okay, so here's the crest of a coaster hill, and here's a coaster car at the top of the hill. And let's say that this coaster hill has a radius r. And let's draw a Freebody diagram of one of the people in the car. Okay, so I'm going to draw that right here. So one of the forces, of course, is the person's weight. And the person's sitting, so there's a normal force upward. Now, since this person is going around on a curved path, it's going on a curved path, there has to be a net force acting on the person to divert that person from the straight line path that they naturally want to follow. And that has to be provided by these two forces. So when you add the weight of the person to the normal force, keeping in mind the directions, of course, you end up with a net force downward. Now I'm going to call down positive. So we have weight down minus the normal force. Okay, so that's the net force acting on the person. And that's equal to the mass of the person times the acceleration of the person. Now, this person is in circular motion, so we can express the acceleration as v squared over r. This quantity here, weight minus normal force, is the net force, but it's also center directed. So this quantity here is actually the centripetal force, Fc. Okay, so now we could solve for Fn, which would be what a rider or the rider feels he or she weighs. So solving for Fn, we get the weight of the person minus mv squared over r, where the weight of the person from Newton's second law is mg. Factoring out the person's mass, we get that quantity, which shows us that the normal force is going to be less than the person's actual weight. So the person will feel lighter at the top of that hill, the crest. Okay, now let's take a look at the dip of a coaster. Okay, the dip. Okay, so here's the coaster car in the dip. Okay, the curve has a radius r. Let's draw a Freebody diagram of the person in the coaster car. So you have the weight of the person, of course, and then you have the normal force, Fn. Now, the coaster car naturally wants to go on a straight line path, so to divert it from that path you need a net force, and the net force would have to act upward toward the center. So if I call up positive, we have a net force of Fn minus the weight, and that's the centripetal force again. And acceleration is v squared over r. So here we could solve now for Fn and see how the rider feels in the dip of the hill. So we have Fn is equal to weight plus mv squared over r. So you can see that this person is going to feel heavier than they actually weigh.